As regulations on operating efficiencies of air conditioning and refrigeration systems drive towards minimum efficiency performance standards, attention is shifting to the uncertainty in performance of the various components that make up these systems. With compressors, published ratings denote the mean performance, as indicated by the nominal performance line in the center of this chart. But the variation from the nominal performance can be traced to 5 primary sources. First, measurement system uncertainty. Differences in instrumentation coupled with other factors such as refrigerant properties, oil circulation, test point deviation, and stability of operating conditions will have an effect on both the power consumed by the compressor as well as the capacity that it delivers. This measurement uncertainty can be as high as 1.3% in power and 2.1% in capacity. Second, lab-to-lab uncertainty. No two labs ever achieve absolutely identical test results. They deviate differently from the set point operating conditions, have minor differences in the calibration of their equipment, use both direct and indirect calorimetry methods, experience fluctuations in electrical grid quality, and may use different refrigerant blend compositions. These differences are subtle, but they can add up to uncertainties of 1.2% in power and 2.1% in capacity. Third, manufacturing variation. Even when manufacturers work hard to maintain quality and consistency throughout their operations, different manufacturers will find variations in compressor clearance volume, machining of parts, electric motor efficiencies, internal gas leaks, bearing alignments, and mechanical losses in friction surfaces. Again, these differences are minor, but they add up to as much as 1.5% in compressor capacity. Fourth, performance prediction uncertainty. Curve-fitting compressor performance maps using 10 coefficient equations require a significant number of test points to provide reasonable regression accuracy. 10 test points would yield a perfectly fitting equation, but this would not reflect the true mean performance of the compressor. Increasing the number of test points brings the equation closer to the mean. Both system and component manufacturers need to balance the number of tests needed to improve accuracy with the time and effort to do so. The result: these modeling errors can represent a difference of as much as 4 to 5% for both power and capacity. And fifth, differences between tested conditions and rated conditions. Sometimes labs find themselves testing under conditions that are slightly different from rated conditions, but still within the limits of the standard. These differences can add up to 2% uncertainty in power and up to 1.5% in capacity. When you consider the total potential impact of these 5 independent uncertainties, they can add up to a significant total uncertainty in a compressor's published ratings for power and capacity, up to 4.9% for power and 5% for capacity. What's worse, the impact of these uncertainties tends to grow at lower evaporating temperatures and higher pressures. Why are these uncertainties a major concern? Compressor performance standards AHRI 540 and EN 12900 allow only limited tolerances. Capacity tolerances range from -5% at high evaporating temperatures to -10% at low evaporating temperatures. Efficiency tolerances applicable to COP or EER are generally down to -10%, but only -5% at some specific rating points. So, is it possible to manage or eliminate these uncertainties? Manage, yes. Eliminate, no. The impact of these uncertainties can be minimized by using more accurate measurement systems, relying on a single lab for data generation, decreasing manufacturing tolerances, selecting a broader, more precise range of test points for systemic validation testing, and testing at rated conditions. By focusing on these 5 steps, it is possible to manage the uncertainties but not to eliminate them. Obviously, this video is too short to fully explain these basic uncertainties in compressor performance. So, to learn more, please download this AHRI compressor section white paper on tolerances and uncertainties in performance data of refrigerant compressors at this link.